So we're in 3.1, pairs of lines and angles. Parallel lines are coplanar lines that do not intersect. They are coplanar lines that do not intersect. Coplanar lines that do not intersect. What does coplanar mean? They're on the same plane, okay? Go ahead and make sure you have the letters L and M like you see in the picture. They're not on your notes, but they need to be the letter L and the letter M. So, as they are right now, they are not parallel. What would need to be on both of them in order to show that lines are parallel?
The caret symbol.
The little carrots. So they either look like this, where they're carrots, or they might also look like triangles. So we're going to change this first one into triangles, because you will either see triangles or you will see carrots like in the second one, or little arrows, however you want to call them. We'll go ahead and draw them on both. Alright, so that indicates that lines are parallel. And then what was the symbol for parallel lines? Yeah, two straight lines, right? Let's go and write that in for the symbol. They're just two vertical straight lines, and they mean is parallel. So I believe that is a blank. The symbol for parallel lines. And then let's say we wanted to name these two lines parallel. How would I name this first line? Line L. And we would say is parallel. So we got line L is parallel to line M. Line M. The second we would name a little differently. We don't have a lowercase letter, we have 2 points. So when we use 2 points, what does the symbol look like above? A line and 2 arrows, yeah. So line AB is parallel to line CD. So again, tomorrow we'll look at a map and pick some parallel streets and go from there. These are parallel. We're going to talk about perpendicular next. So perpendicular, there are coplanar lines that intersect and form right angles. Coplanar lines that intersect and form right angles. Coplanar lines that intersect and form. You could put 90 degrees if you don't want to write out right angles. They intersect and form 90 degrees. So what do you look for perpendicular lines?
Upside down T.
You look for the 90-degree angle box. But the symbol to note that they are perpendicular is an upside down T. So like this. So we would say line T is perpendicular to line M. That is the symbol, an upside down T. So line M is perpendicular to line N. And then it says key facts. We've already talked about this before. How many degrees is a straight angle? 180. So we already have 90 degrees of it. So what does the other portion of the 180 have to be? 90. So it's understood that there are actually 4 right angles. They only draw one. So there are 4 right angles formed. That's the key fact. I believe it's the blank in the middle. 4 right angles are formed. Four right angles are formed. You're good? All right, and those are perpendicular. Questions, comments, concerns? Okay. This next one is new, but it was on your project, and there's skew lines. Skew lines. So here's what you're going to write. They do not intersect. They do not intersect, and they are non-coplanar. They do not intersect, and they are non-coplanar. They do not intersect, and they are non-coplanar. They do not intersect. They're not coplanar. All right, so if you look in our picture, you've got these two green lines. The plane that the bottom green line is on is the ground, and the plane that the top green line is on the bridge. They will never, ever intersect. So if we look in our room, there are a lot of lines that will never intersect if they kept on going. So if you look at the top of my board, as an example, so like this silver thing at the top of my board, if it kept on going and going and going, it's on the plane of my board. If I use the side of Devin's desk and it kept on going and going and going, they would never intersect and they're not on the same plane. So they would be called skew lines. So in the context of our class, you'll look at a box and find some skew lines. So we're actually just going to pick a line to start with. So pick a line, any line. GC. Sounds good. Let's go ahead and highlight it. We're going to figure out what is skew with GC. So skew lines do not intersect and they are not coplanar. We're going to focus on the not coplanar part. So what would be helpful is to know what part of the box, what planes GC is a part of. So I'm going to use this tissue box. We're going to use words like top of the box, bottom of the box, sides of the box, front, back of the box. Are we okay with these words? Top, bottom. So GC is this segment. What parts of the box is it a segment of? The front and the side. So we're actually going to outline that for a second. If you just want to use your pencil. It is a part of this side of the box and the front of the box. Why did we do that, Miss Marshall? Because in order for you to have skew lines, they have to be not on the same plane. We just highlighted what was on the same plane as GC. So anything that we just outlined is not skew because it is on the plane with GC. So we can name any of the other line segments as long as they do not intersect with GC. So we could say AB, if you want to go ahead and write that down. We're going to say GC and AB. There's no symbol for skew, so you can just write the word and. I usually just write the little and symbol. This is just one example of skew lines. GC and AB. What else would be skew with GC? EF is one of them, and then there's three more actually. EA, AD, and then EH is the last one. So any one of those you could have named as skew to CG. Do we need to do it again, maybe practice, or do you feel okay about it? Feel okay? All right, let's go ahead and flip to the next page. We're going to talk about parallel planes. Someone asked me earlier, because perpendicular planes isn't on our notes, it does still exist. Perpendicular planes are planes that intersect and form 90 degrees. So like the ground and the walls and the ceiling, they exist. We're just going to talk about parallel planes for now. So all planes either intersect or are parallel. The definition of parallel planes are planes that do not intersect. So do not intersect. So planes that do not intersect. Planes that do not intersect. So what in my picture represents parallel planes? The steps. So you can look at the top of the steps are all parallel. The front of the steps are all parallel. Things like that. But again, we're going to look at it in context of a box. So the parallel sides would be the sides of the box, the top and bottom of the box, the front and back of the box. We're going to name them parallel. Which sides of the box, of this box, do we want to name parallel? There are no wrong answers. The sides, the front, the back, the top, the bottom. The front and the back. All right, so go ahead and highlight the front. We're going to name it parallel to the back of the box. Whenever we name a plane, what do we write first? Plane. And then how many points do we use? 3. So pick 3 points from the front of our box here. DHG. Sounds good. So we want to say plane DHG is parallel. Let's go and draw those 2 vertical lines. Is parallel to plane. So the front of the box is parallel to the back of the box. I highlighted that part as well. The front parallel to the back. So what 3 letters will we use to name that part? Which one? That sounds, yep, BFE sounds good. So plane DHG is parallel to plane BFE. There you go. Oop. Questions about parallel planes? Wonderful. So we're going to use this example. So 2 things we're going to outline before we even start. It says think of each segment in the figure as part of a line. Let's go ahead and put a box around it. So if we're thinking of them as part of a line, we're going to name them like a line, which means with arrows and all that. The second thing is we're going to underline the containing point A. Because a lot of students who get this wrong on like a classwork or on like a test, it's because they didn't read what point to go through. So we have this box. It's a little different than our previous box. They didn't put dots at every intersection. They normally don't. But just know that G is a point, H is a point, A is a point. They're all points here. So the first one says we're going to name line or lines parallel to CD through point A. So what line or lines is parallel to CD through point A? Go for it. That's correct. BA, AB. We can pause for a second. Draw 3 columns. So draw a box. Draw 3 columns and 4 rows. So 3 columns, 4 rows. We're going to put parallel in the first, perpendicular in the second, skew in the third. So parallel, perpendicular, and skew. Each of their definitions mentioned whether or not they were coplanar. So that is the second column's name. Each of them mentioned they're coplanar, and each of them mentioned if they intersect. So let's go through it. Parallel lines, are they coplanar? Are they on the same plane? Yes. Do they intersect? No. Perpendicular lines, are they coplanar? Yes, they're on the same plane. Do they intersect? Yes, they have to, right? What do they do when they intersect? They form 90. And then skew, are they on the same plane? No. And do they intersect? No. So BA was the only answer for parallel through point A at least. Because they're on the same plane. They're both on the top of the box. And it goes through point A. What if I didn't give the specification of through point A? What other line would be parallel to DC? FE would also be parallel to DC if it didn't say through that point A. Letter B, it says skew through point A. So skew lines, they're not on the same plane, and they do not intersect. So what part of the box is CD a part of? We already said it was a part of the top and the side, right? The left side. So when we name a line skew, it cannot be a side that CD is coplanar with. So what line or lines is skew with A? HE is, but it doesn't have point A. AH is one of them. And then I heard AG would be the other one. So we want to make sure we contain point A. BG is technically skew, but it doesn't have point A. HG is technically skew, but it doesn't have point A. FG is skew, but it doesn't have point A. We just wanted to go through point A. The reason they do this is because we would be writing a lot of different answers for all these questions. So we want to narrow it down. Letter C, perpendicular. So perpendicular through to CD containing point A. So what intersects with CD and forms 90 degrees? Yeah, DA. Or AD, however you want to say it. DA, AD. And last, we want to name a plane that is parallel to EFG. What part of the box is EFG? The bottom. So we want to name the top of the box. Correct. So you want to contain point A. So we'd have to list the letter A somehow. That sounds fine. DAB, ABC, DCA, CA, CDA, anything like that. Questions on this one? Wonderful. Go ahead and put a star next to this one. This is what it will look like on your quiz and test. So we'll have like a map, and then you'll want to name parallel lines, perpendicular lines, and so on and so forth. So the first one, we want to find parallel lines. What do we look for to name parallel lines? The little carrots. Do we see some? Yeah. We do. So we want to name these lines parallel. Technically, they're not lines though, right? They are rays. So let's name the first one. When you name a ray, you have an arrow pointing to the right. This one was harder for students because you have to really look at the picture. What is the starting point for this ray? D, and it goes in the direction of M. A lot of people, so M is right there, right? A lot of people tried to say A. Why can I not say A? It's not on the line. It looks like it is because it's right next to it, but it's actually on this crooked line. So we have DM, and then it's parallel. So we want to use the parallel symbol to EF. Correct. This next one, we're going to name a pair of perpendicular lines. What do we want to look for perpendicular? Right angle. Right angle. We see one. So you just want to name the two lines that the right angle sits on. So on this side, it sits on this line. So it is a line. We'll name it with, 2 arrows. And then pick 2 points on the line. BM. BM, sounds good. You can say BM, MB, FM, FB, MF. I think that's all of them. And then is perpendicular. So you get the symbol. The right angle sits on this ray as well. So we'll name the ray. Hopefully you can see that. I can move it over. And then what would we name that ray? Yeah, DM. All right. Last says is FE parallel to AC. Are they parallel? No. There's actually 2 reasons that you could write. It does say explain, so we do need to explain. So what is one of the reasons it is not parallel? Doesn't have the carrots. I'm going to put the word triangles. But triangles, carrots. What's the reason number 2? They will eventually intersect. So either reason would have been perfectly fine. And when you're ready, we flip to the back. So this chapter really repeats over itself. We learn the basics of it today. And then we'll learn about it again tomorrow and the next day and the next day. All of this chapter is about what we call a transversal. Sounds really complicated. It is the top word on that last page. A transversal is a line that intersects two or more lines. That's it. Transversal is a line that intersects You can put 2 plus if you don't want put 2 or more. 2 plus lines. Technically, it is at different points. So here's what that means. There would not be a transversal here because all of these lines intersect at one point. Does everyone see that? A transversal is when one line intersects 2 or more at 2 separate locations. So it could look like this. Oops, I missed. It could look like this. But really, a transversal is one line that intersects 2 or more. There are special relationships built by a transversal, and that's what we're going to go through today. The relationships that we learned last chapter, they still apply. So what relationship does angle 1 and angle 4 have? They're vertical. What do you know about the measure of vertical angles? They're congruent. So you remember that? Keep that, because it still applies. What about 1 and 2? What relationship do they have? They're a linear pair. What do you know about their measures? They add up to 180. So keep those 2 in mind, because that's not going to be new information for you. You have 4 new properties that we're going to learn, which is why you have 4 highlighters. So the first one we're going to talk about is called, and this could be a transversal too, sorry. It could be turned to the side. Which of these lines is the transversal? Which line touches 2 or more lines? The middle line, yeah. All right, corresponding angles is the first blank in the top left. Corresponding angles, here's what's going to happen. You have 2 intersections, right? 1, 2. Corresponding angles are angles that are in the same place at their intersection. Here's what that means. There's a top left, right, in this top intersection. There is also a top left in the bottom intersection. They are corresponding angles. So what you're going to put, you can either write 1 and 5 and then highlight them, or you could highlight 1 and 5, however you want to do it. But 1 and 5 would be corresponding angles. They are both in the top left of their intersection. So I would write them down. I would make sure you highlight them so you could visually see 1 and 5. So they're both in the top left. In the top right, they will also be corresponding. So top right would be angle, if you had to guess, angle 2, and in the top right of the bottom intersection, that would be angle 6. So 2 and 6 are also corresponding. Don't memorize the numbers, memorize like where they're located, right? Both in the top right, they're going to be congruent to each other. So you got top left 1 and 5, top right 2 and 6. They'll be corresponding. All right, the next one, you got 3 and 7. Bottom left. They are corresponding. And then last, you got bottom right and bottom right. So 4 and 8 would also be corresponding. I accidentally said it already, but you can write it down. What if you had to guess about their measures? If they're in the same spot, what could you guess about their measures? They're going to be the same. They're going to be congruent. So if you want to write in that box that corresponding angles are congruent, we will learn it in 3.2, but if you already get that ball rolling, you can remember. So they're in the same spot. They're going to be the same measure. All right, these are corresponding angles. Questions, comments, concerns? All right, we're going to move over to the right. Right, that's alternate interior. So in order to see interior, at the beginning I usually have students close the gap between the 2 lines. So go ahead and draw like a box between the 2 lines. Because what does interior mean? Inside. On the inside. So we're talking the inside of the double lines and then alternating. When you alternate, what do?
Switch.
You switch, right? So here's what's going to happen. 1, 2, 7, and 8 are exterior. That's why they're in black. They're not a part of what we're going to do right now. Alternate interior are on the inside of the double lines and on the opposite sides of the transversal. So you're going to do 3 and 6. 3 and 6. That's the first one. 3 and 6. They're on the inside of the double lines. And they're on opposite sides of the transversal. 3 is on the left. 6 is on the right. That's what makes them alternating. So 3 and 6, the other set will be 4 and 5. Still on the inside of the transversal. 5 is on the left. 4 is on the right. Those are alternate interior. I can go ahead and let you know now. Alternate interior angles are going to end up being congruent. We'll talk more in depth about why in a little bit, but your Kahoot today will ask. So we had 3 and 6, 4 and 5. Alternate exterior. So alternate exterior, they're going to be on the outside of the double lines. So again, if you want to close in, your between your double lines, make a little box. They're going to be on the outside of the double lines and then alternating across the transversal. One will be on the left side, the other will be on the right. So that'll be 1 and 8. So 1 and 8. And 2 and 7. One and 8, 2 and 7. All right, and then last is consecutive. Oh, sorry, before we get to that. You could have a transversal that's turned sideways like this. If you did, which of these would be alternate exterior? 1 and 8, and then 6 and 3, right? And then if they were alternate interior would be 2 and 7, and then 4 and 5. So even though it's turned on its side, it's still between or outside the double lines. All right. The last one that's new is consecutive interior. So when something's consecutive, it's back to back, right? So instead of alternating across the transversal, they're actually on the same side of the transversal. So consecutive interior will be 3 and 5. 3 and 5. And then 4 and 6. 3 and 5, 4 and 6. So 3 and 5 are consecutive interior. 4 and 6 are consecutive interior.